Hi, this lesson is on searching operation for arrays. After completing this lesson, you'll be able to tell the basic concept behind searching and understand the algorithms of sequential search as well as binary search. So here it deals with the inputs, the array where a specific value is to be searched, and output, it returns the position of the search value, that means the index or subscript within the array. And as for processing, it can either use a sequential search or the sequential search is quite simple. It searches the value from the beginning of the array and in a sequence till the desired element is found. And in that process, it basically compares the search value with the array elements one after another. If the element is matched, it returns the position of the index, else it returns some error condition like -1. And sequential search is typically applied on some unsorted array or a list with few elements. For understanding the algorithm of sequential search, please have a look at this diagram. See, here it is searching one after another element in the array and then finally getting the match. So, initially we are not sure whether the match will be found or not. So, we are assuming that pos is -1. That means not yet found. And then we need to search within a loop for the array elements. So naturally, the starting position will be the first element. So index is 0. And then within the loop, we are searching whether the current array element is matching the value. If it is matching, then we know now the current index value is basically the search position and we are printing the position value. And in that case, we can safely come out of the search algorithm. But if the match was not found, then basically we are just incrementing the index, checking the next array element, and in that way. So, in that way, the loop gets executed, and even after completing all the array elements here, if the match was not found, then we can safely say that the search has failed, and in that case, the position remains at -1. If there are n number of elements in the array, and if the search value is not present in the array over here, then you can see that it has to search through all the elements, and that is like the worst case. So even after n number of checks, that is the worst case, the element was not found. Also, it doesn't matter whether the elements are in sorted order or not for sequential search. On the contrary, the binary search can work only if the array is already sorted. Under binary search, it compares the search value with the mid element of current array. If the value is matched, then well, the search has been successful and the array element position can be safely returned. Where, on the other hand, if the value is less than the mid element, then the search value will be lying somewhere in the left half of the array. And if the value is greater than the mid element, then the search value is expected in right half of the array. So now we have shortened, rather we have squeezed our searching scope. So either on the left or the right half of the array, now the search procedure is to be repeated. So binary search is typically used in case of a large size array. So refer to this animation where you can see that there are 17 elements in total for this array. So first it finds at the mid element. So it didn't match. So now the check will be in the right half. And in that way, it is progressively finding the mid position and trying to match. Take a pause and look at the animation carefully. So, have you noted that for the same array, binary search required only 3 number of checks, whereas sequential search took 11 number of checks to identify 37 in that given array. So here for the binary search, we are using the array parameter, and in the first index, which is 0 for the LB, lower bound, and the upper bound is for the last index position, which is 16 in this particular example, and val indicates the value to be searched, which is 37 for this example, and POS is the output parameter where the position of the array element, I mean where the match has been found, is to be populated. So POS is the output parameter and rest all are the input parameters. We are now using a couple of intermediate variables like low, high, and so low is set with initially set with LB, high is set with UB, and initially, I mean, we are not sure whether the search will be successful or not. So POS is initialized with -1. Now we are repeating these two statements, okay, and that is to be done as long as the low is less than high. So what we are essentially doing, we are finding the mid position, and then the element at this mid position is compared with the search value. If the match has been found, then we can safely populate the output parameter POS with the mid position, and we can print the position value because the match has happened, and we can safely exit. If the match has not happened, then we need to check whether the mid element is greater than the search value. So in that case, we need to search in the left side array, left half of the array. So for that reason, we are assigning mid -1 to high, because mid has been already checked and there is no scope of getting this search successful in the right half. And if that is not the case, so the mid element is less than val, then we know that so in this case the search value is expected in the right half of the array. In this way, this search logic gets repeated, and at the end it can either match with the search value or it can reach a position where the search has been exhausted, the full array has been scanned in this way, and in that case, I mean in the later case, it is going to return the error value. Okay, so these are the references. Thank you.